Hi everyone, welcome to this lecture series on Oracle Cloud Infrastructure Foundations. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this particular module, we will look at some of the OCI networking services. Specifically, we will look at what a virtual cloud network is, what kind of gateways are available in Oracle Cloud Infrastructure, what peering options do we get, what do we mean by security controls within VCN, and we'll briefly talk about load balancer service within Oracle Cloud. So first let's look at what is a virtual cloud network. A virtual cloud network is a software-defined private network that you set up in OCI. What do we mean by software-defined? What we mean here is you get access to the VCN, but not the underlying hardware because it's all in software. What is the need? Why do we need a VCN? Well, it enables your resources such as compute instances to securely communicate with the internet, with other instances running in Oracle Cloud Infrastructure or your on-premises data center. So those are the three key scenarios where your instances need to communicate. And in order to do that communication, you need to have them running inside a virtual cloud network. Well, so what does the virtual cloud network looks like? As you can see here, I have a couple of instances. One instance is talking to the internet, other instance, and these are talking to each other as well. Other instance is talking to your on-premises environment. So in order for us to enable that communication, we take a region. A region has ADs, one or many, one or three, multiple. So in this case, we are showing just one AD. And in this particular example, we create this VCN. And as you can see, the reason we have this as a dotted line is to show this is sort of a logical thing. It's not a physical thing. It's a software defined construct, the VCN here. And then, we have these compute instances running inside the VCN. So like we said, a VCN lives within an OCI region, and it's highly available, secure, scalable, all done in software. So it inherits all those constructs. Now let's dive a little deeper. When you create a VCN, first thing you do is you give it an address space. So address space is nothing but a range of IP address that you assign, right? Like in this case, you have this IP address of 10.0.0.0.0/16. Now, what do we mean by an IP address? Well, think about IP address as like your postal address. So this is a unique identifier for all the um, equipment, all the assets by which you can identify an asset. So typically what happens in an on-premises environment, or at least in the traditional environment, is you have this concept called a DMZ, demilitarized zone, and then you have your local area network here. And as you know, IP resources, addresses are a precious resources. So many years back, the standards for RFC came up with this idea of or concept of RFC 1918 addresses. And basically, these addresses are called private address space. And the idea here was to preserve the public IPv4 addresses, the number of IPv4 addresses we could have, and also prevent overlapping of IP addresses. So these addresses, the reason they are called private is they are not routable on the internet. So your LAN could use these resources. So if you have a computer here, you have a computer here, you have a computer here, they could all have private IP addresses, but your DMZ can have a load balancer which will have a public IP address. If you just go and get the public IP address of your local machine, which you are where you're watching this video right now, you will get an IP address which is publicly routable. So it can be discovered on the internet, right? So that is a public IP, and then organizations have used the private IP addresses. There are three ranges here, and we don't have to go in detail on these ranges. There is 10.0/8, there is 172.16/12, and there is 192 168.168/16. Now again, we don't have to go into all these details, get into a lot of complex site annotations, etc. But the idea here is, let me just remove this one second. The idea here is that using these private IP addresses, your resources can still be identified on your local LAN network, but they cannot be routed on the internet. So when we talk about VCNs, what we are talking about are these private IP address spaces, right? So you look at that 10.0.0.0/16. That's a private IP address, right? So first thing you do in a VCN is you assign that private IP address, right? Now it's a range, as we talked about, right? So this particular CIDR means these are the IP values which you can assign to your resources. Now, every resource that is connected to this VCN, like a compute resource, will get its own unique private IP address. Remember, it's private IP. So the server one has this IP, and this particular server has this particular IP address. Now, how did those servers get those IP addresses? Well, the idea here is you take this big network and then you divide into these things called subnetworks, smaller networks. Now, why do you do that? Well, first, these are the examples here. You could take a bigger network, you could divide it into smaller networks. Well, why would you do that? The idea is your compute instances are placed in subnets. You cannot put a compute instance just here without a subnet, without in just a VCN. You have to create a subnet, at least one. And then subnets can be isolated and secured. And this is one of the big reasons why you would have subnets, because you could run security here on a subnet. Now, let's look at the communication pattern we talked about, right? Why did you create a VCN in the first place? Well, we want instances to communicate, right? So the first scenario is communication to the internet, right? So the simplest scenario is you are running a web server here. Let's say this is your web server and you want the traffic to go out, right? It's a web server, it's a load balancer. So in OCI, there's a gateway, which is called Internet Gateway. It provides a path for network traffic between your VCN and the internet, and it's bidirectional. So you can go from here, it can come from the internet. People on the internet could actually discover it, right? It's a web server. You want it to be discovered. You know, folks can ping it and access it. So, well, you guessed it. This you would put in a public subnet. Also, sometimes people call them as DMZs. Not every public subnet, but there is this concept where you put all your public-facing assets in a subnet which is public, called a demilitarized zone. Now, on the other side, you might still want to reach the internet, but you want to reach it in a secure fashion. So what that means is, let's say you are running a database here, and your database needs patching, of course, right? So for it to get the patches, it still needs to go to the internet and get the patches back. But what happens is, a bad actor should not be able to ping the database from the internet. And so you would use a gateway called a NAT gateway, which enables this outbound connection to the internet, but blocks inbound connections initiated from the internet. So this bad actor cannot reach your database, right? Use cases, updates, patches. Both these gateways are highly available, secure, and scalable. So this is the whole idea of software-defined networks. You don't care about the throughput, whether they are highly available. We manage all that, and we make these fault tolerant for customers. The second scenario is you want your communication to on-premises. Well, you're running in a hybrid mode. You still, let's say you have a DNS server which is running right here in your on-premises, and your databases need to get the DNS to sync up with the DNS server, right? So what you need to do here is let's say you're running a database, you need to go to on-prem, right? So in this case, you have another kind of router called a dynamic routing gateway, and it's a virtual router that provides a path for private traffic between your network and destinations other than the internet. So you're not going to the internet right now. You're going to your on-prem environment, and you use a router called a DRG. Now there are two kinds of mechanisms, or two kinds of design you have with a DRG. One is what is called a simple, IPsec VPN, also sometimes referred to as site-to-site VPN, because you're connecting sort of two sites. And there is another, and this actually goes through the internet, this traffic, but we said that it's a private traffic. So what it means is we encrypt the traffic, and that's the IPsec encryption in the name. So we encrypt the traffic there. Now the second design is around using a private dedicated connectivity. So think about this as having your own high occupancy vehicle lane. If internet is this massive, set of highways, and you get your own vehicle lane, and it's only for you. It's private, and it's a dedicated connectivity. And again, this is a foundations course, so we're not getting into lots of details, but you can, get into a lot of details on how each of these work and the components. Now there is a third scenario where you want to communicate, this time, to public OCI services like an object storage. As you know, object storage has a public endpoint. It's a public URL through which you can access it. It's for the storage for the web. So let's say you have a scenario where you want to access object storage. Why would you do that? Well, again, as in the previous examples, let's say you have a database running here. You want to take backups of those databases. The best place to keep the backups is in object storage. It's built for this massive scalability, reliability of data. So you want to do the backups. Now to do the backups, you want to access a public endpoint. Now by very virtue, it means that this subnet has to be public, and this instance needs to have a public IP address, and so on and so forth, right? So it becomes a security issue if you go that way. So we have another gateway in OCI called a service gateway, which lets resources in networks, VCN, access public OCI services such as object storage, but without using an internet or a NAT gateway. So your traffic is not going over the internet, it's still going through the Oracle private network fabric. So as you can see here, we use the instance private IP address for routing, and it travels over the OCI network fabric, never traverses the internet. The use case, you have to back up your database. That's the most common use case, and there are several other use cases, but this is a way for your services to access public OCI, your resources to access public OCI services, but not go through public internet. Well, so we looked at the four different kinds of gateway. Going to internet gateway, NAT gateway, different use cases. We looked at dynamic routing gateway, going to on-premises, going to public OCI services such as object storage. We looked at service gateway. So four very common gateways. You should know the use cases for each of them. Now, briefly, let's look at security. So in this case, we have similar example as before. We want to secure these instances, because remember in the previous slides we talked about the fact that you have subnets. You want to secure these subnets, and of course the compute instances running within the subnet. So what you could do is you could design a set of firewall rules. You could put a firewall which would say what kind of traffic is allowed in and out of the subnet. You could do that. Now, security list also apply if this instance wants to talk to this particular instance. You need to put a security list here in order to enable the traffic. So one thing you need to keep in mind is you create a network, you have subnets, and these are all secure by default. So it doesn't mean that this instance can talk to this other instance just because they are in the same network. You have to enable that traffic. And then you could do stateful, stateless, and again we're not getting into lots of details here, right? So let's look at a couple of examples. This first one applies to the web server. It's saying port 80, traffic coming from anywhere, allow that port. Ingress meaning it's incoming. The second one is applying to this guy here, on the private subnet. It's saying it's egress, going out, only allow traffic to this particular subnet, and only allow traffic on port 1521, right? So this is how you would secure your networks. Just think about these as your firewalls sitting on the subnet and controlling access for all the resources, or for all the resources like compute instances within that subnet. Now you don't have to always put these at the subnet level. We have another feature called network security group. Basically, you could do the same thing, but now you could do it at the virtual NIC level. So what that means is you could apply NSG just to this particular instance, and so on and so forth, right? So it gives you more granular control of how you handle your security. So remember, you could apply security either at the virtual network interface layer, or you could do it at the subnet layer, and there are different use cases of when you would use one over another. Well, so that was we talked about the gateways, and we talked about security. Those are sort of the basic scenarios, right? The one other scenario for communication we actually missed in the previous slides, right? And that's around peering. So what I mean by that is, let's say you have a region here, right? All the previous scenarios were like focused on one region. You have different gateways. Now let's think about this way. In a region, let's say you have multiple VCNs. Now you still might have a scenario where these VCNs have resources you want to communicate, who want to communicate with each other. Why? Well, good example might be that DMZ has its own VCN, right? And your other, your other uh, assets or other projects or other, units have their own VCN. It's a very valid scenario. So your VCNs might want to communicate with each other, and so the process to connect these multiple VCNs is called peering. Now, in a peering, there are two kinds of flavors which are possible. One is called local VCN peering. It's in this process you connect two VCNs in the same region. So you're in the same region. So their resources can communicate using private IP addresses. So this guy can talk to this guy. You create something called a local peering gateway, and the communication happens. Now, what if you have VCN in other regions? And we talked about the fact that many regions have region pairs, so two regions existing in the same geopolitical area, or even if they are in different areas, you might do things like global rollouts. You might do things like disaster recovery, right? So you might still be talking between two different regions. So in that case, you have this concept or this construct of remote VCN peering, similar to local VCN peering, but now you're connecting two VCNs in different regions. So their resources can communicate using private IP addresses. Now, the thing to keep in mind is you have peering here and you have peering here. This doesn't mean that the peering is transitive. So it doesn't mean that this compute instance can talk to this compute instance. This kind of communication is not allowed. If you want this instance to talk to this, you have to make a explicit peering connection, meaning the peering is not transitive. All right, so we looked at different scenarios around gateways and security and peering. Let's look at the last topic in this lecture around load balancer. Well, why would you use a load balancer in the first place? Well, load balancer is this construct which sits between your users or your clients and your backends, right? The first thing you would use a load balancer is so in a load balancer, what you do is you requests are coming in from the clients. You do things like service discovery. You say what backends are available and when should we talk to them, right? You also do health checks. So if this one has gone down and these are healthy, you stop sending traffic to them, right? Why do we use a load balancer, right? Well, we use a load balancer. The first reason is high availability. We looked at it in the previous module. If these three web servers go down, you still have a web server, you still have your application running because one of the web servers is running, right? So you do that. Second is scale. One VM can only handle this much traffic, or a bare metal machine. If you put four of those, of course you get a bigger scale. So those are the two common reasons why you would use a load balancer. Now in OCI, we have different kinds of load balancer. We have a public, we have a private. It operates at layer 4, operates at layer 7. You can do things like session persistence, affinity-based routing, complex kind of routing. You can do SSL. There are lots of features, right? So in this lecture, we are not going through this. I'm just going to show you a common, simple example. So let's say you're running a public load balancer. Traffic is coming in here like this. First thing we talked about is the services. OCI services are fault tolerant. What does that mean? This can become a single point of failure. To avoid that, we always maintain two copies of the public load balancer or the private load balancer. So if this one goes down, this load balancer is still running. You don't have a single point of failure. And then, as we looked at the previous slide, this load balancer is basically sending traffic to the various backends. In case if this one goes down, the traffic will switch over, the IP will switch over to this load balancer, and then the load balancer will still keep sending traffic to the various backends. Well, that's all we wanted to cover on the virtual cloud network. In this particular module, we looked at what a virtual cloud network is, software-defined network, highly available, secure, scalable. We looked at different kinds of gateways, internet gateways, NAT gateways for sending traffic to the internet, different use cases. We looked at DRG, dynamic routing gateway, for sending traffic to on-premises. We looked at service gateway for sending traffic to public OCI services such as object storage. We looked at peering, both local peering as well as remote peering, and different use cases why we would do one versus another. And then we looked briefly at a public load balancer. Well, that's it, folks. Thank you for your time and joining this module. In the next module, we'll talk about some other OCI services. Thank you.